I apologize for going on about this. You can always skip this video if you're not completely captivated, or if you're lost, which I expect I would have been at this stage in this course. If you're interested enough, you can dig this out. Anyhow, we can actually perform this integral. This is not a difficult integral. So we have the integral from 0 to pi over 2, the integral from 0 to 2 of 2 cosine squared y divided by 1 plus u plus 2 sine squared y divided by 1 plus u quantity squared du dv. Now, put this under here for the moment. Might be tempting to do some factoring with the 1 over 1 plus u, but I don't think that would be a good idea. Easy enough to integrate as it is. Integrating with respect to u, 1 over 1 plus u, the integral is a natural log of u. So we have 2 cosine squared y, natural log of 1 plus u. Plus then, that integral of 1 over 1 plus u quantity squared is negative 1 over 1 plus u. Now you can go through substitutions and so forth and get that, but that's going to be 2 sine squared y over 1 plus u, and that'll be a negative. This is all evaluated between 2 and 0, and then this should be v, not y, so let's kind of change those y's to v's. Okay, this integral evaluated at these 2 points, integrated with respect to v. We're just going to get constants, a constant multiple of cosine squared y, a constant multiple of sine squared y. Now, I'm not going to write out everything here. If you're captivated enough to be here, you know how to do these integrals. Substituting 2 in for x, we get natural log of 3. Substituting 0, we get natural log of 1. Natural log of 1 is 0, so we're just going to end up with 2 cosine squared y, natural log of 3. 1 plus u, if u equals 2 is 1/3, at u equals 0, it's, well, sorry, I'm substituting 2 in here, we get 1/3 of the negative 2 sine squared y. Substituting 0, we just get the negative 2 sine squared y. 1/3 and 1 combined to give us 2/3, and the larger number goes with the lower bound, meaning that we're going to have a change of sign here, and we're just going to get 1/3 sine squared y. All that integrated from 0 to pi over 2. With respect to y, I keep writing y instead of v, but there we go. The average value of the sine squared or the cosine squared over any interval that is bounded by multiples of pi over 2, as is this one, is going to be 1/2, so that the average value of the cosine squared and the average value of the sine squared are both 1/2. The length of the interval is pi over 2. The details of the integration of the sine squared or the cosine squared are not bad. You can integrate by parts. You can use special angle formulas. But the bottom line is that this integral is going to be 2 natural log of 3 plus 1/3 multiplied by the average value of the cosine squared or the sine squared, which is 1/2, multiplied by the length of the interval, which is pi over 2. Okay, just numerical approximations. Natural log of 3. 3 isn't much bigger than e. Natural log of 3 is not much bigger than 1, so that's pretty close to 2. Adding 1/3, maybe this is 2.5. So that's maybe 2.5 times 1/2 times pi over 2 is about 1.6. 1.57, whatever number of figures you want to take it to. 0.8 times 2.5 is 2. It's finding that this integral is about 2. I find that a little troublesome because when I sketch out the xy plane region corresponding to this UV region, I think I get something with less area than is indicated here. Follow me. In the UV plane, this line segment here from 0, 0 to the point 2, 0 is characterized by v equals 0, 0 less than or equal to u less than or equal to 2. So what we have is x equal to 2u. V equals 0 gives us cosine v equal 1, sine v equals 0, so that y equals 0. Therefore, in the y versus x plane, we have x equal to 2u, u going from 0 to 2, with y equal to 0. That takes us out to x equals 4, takes us from x equals 0 to x equals 4. That's this path. Again, regard these as parametric equations for the points x and y that correspond to this part of the UV boundary, the boundary of the UV region. The next part of the boundary, v goes from 0 to pi over 2. And u equals 2. So x equals 4 cosine of v, y equals 1 over 1 plus 2 1/3 sine of v. Those are parametric equations of an ellipse from 0.40 to 0 1/3. As v goes from 0 to pi over 2, cosine of v goes from 1 to 0, sine of v goes from 0 to 1, and our curve does this, where this coordinate here is 1/3. So far it looks like we've got just a little over half the area of a rectangle that's 4 units by 1/3, a total area of less than 4/3, probably less than 1. We're looking for an area of about 2, so as I say, I'm just a little bit worried here. It looks like things get weird as we travel along this part of our boundary. Now, so far we've gone from here to here, and we've come from here back to here. On this part of the boundary, v equals pi over 2, which is going to have the effect of making x 0. So we're going to be on the y-axis. And u is going to go from 0, it'll actually be from 2 down to 0. And the values of u from 0 to 2 will actually be taken in the reverse order. And this is going to give us, inescapably, it looks like x equals 0, y equals 1 over 1 plus u. Now when x equals 2, y equals 1/3. That puts us at the point 0, 1/3 right here. If x changes to 0, that's going to give us 1 over 1, so that's going to take us right up the y-axis to the point where y equals 1. So we have, we've moved from the point 0, 0 to the point 4, 0 to the point 4, to the point 1, to the point 0, 1/3 to the point 0, 1. Now, as we go from here to here, along this fourth part of the boundary, we're going to have to go from 0 to 1 back to 0, 0. Let's see what path we take from here to here and how much area we enclose with that path. Let's see now. Along this path, we have v equals 0 and wrong. We have u equals 0 and 0 less than or equal to v less than or equal to pi over 2. Traversing in this direction, going from pi over 2 down to 0, from v equals pi over 2 down to 0 while u remains 0. This is not going to be pretty. V equals 0 gives us cosine v equals, u equals 0, I'm sorry. U equals 0 gives us x equals 0 again. That's what's not pretty, because that's going to keep us on the y-axis and we're not going to enclose any more area. Not only is that a pretty weird shaped path, a pretty weird shaped region, but it doesn't have an area that's big enough to match our integral. Now, just to be sure we really get from here to here, what does y do? Well, y is 1 over 1 plus u. Well, u is 0, so that's just 1 times the sine of v. Now, as v goes from pi over 2 to 0, the sine of v is going to go from 1 to 0. So that's going to bring us all the way back here. So we've climbed up here, and now we're going to come back down, and we're going to end up where we started. This curve is closed, but not only is the region kind of weird, there are points where we take the same value twice. I suspect that there's some kind of an error in my calculation of RU cross RV or something. However, it's all pretty straightforward, so I'm going to kind of leave it to you to check. The area is less than 4/3 because we have a 4 by 3, a 4 by 1/3 rectangle. But the integral tells us that the area should be about 2. Now, either I've done something pretty ignorant with my mental approximations here, and that's always possible, or something with some of the terms, maybe a sign error which would cause a couple of quantities to be subtracted and yield a smaller area. Leave that for anybody who wants to correct. I don't. I'm going to have to move on to other topics. Don't have time to go back and recheck all this. So if you've gotten this far into this topic, you should have no trouble finding my error and reconciling it.